Is it? Okay. So we're gonna meet on, we're not doing the extension problems on this video. We're just going to do the group quiz on this video. And then on Saturday, we're going to all meet together and review the extension problems. That way we can kind of save time, spend time with our families. So we will all take notes, and if there's any questions about it, we can all just email the teacher. So.
Uh-huh.
All right.
All right. So do you guys have the quiz pulled up?
It's pulling up right now.
Okay.
Do you have it up already?
Yeah. So the first problem is just matching each expression with the equivalent expression. So it gives us 5 problems and then, or 5 problems, and then it gives us matching. So on these, I believe that you have to match it based on the identities that we've been going over. So if you see, or if you have the identities pulled up from the resources, we're looking at like sum to product identities, power reducing identities, all those.
Let me pull it up.
Just mine went away. Sorry. Hold on.
No worries.
I got a million screens up right now.
I have so many tabs.
Okay. Almost there.
No worries.
I'm there. I'm just looking through the identities, seeing what could match.
Yeah, so I kind of actually went over this a little earlier just to see what we were dealing with, and it actually doesn't, it's honestly not that bad.
Oh, really?
Okay.
Yeah. It's just like matching them is like, it's very easy, honestly. Just as long as you have the resource identity page pulled up, then you can figure it out, no problem.
The identity pages? Okay.
So how would you explain that on the paper? Just would we just write out that because of the identities?
So yeah, no, so what I have here is the list of them.
Uh-huh.
And then all I'm going to put is like A, B, C, D, or E.
Okay.
And then I'll explain it, or we'll explain it because we'll like explain what it means.
Yeah.
So like for the first one, do you have it pulled up now, Monique?
Yeah, let's pull up.
So the first one, so sign of 6. So that one's going to be C because of the -6 in the inside. That's going to cause the negative on the outside of the sign to turn into a positive.
Uh-huh.
So it all turns into a positive sign 6. And then sign 6 minus sign 4. So if you look at the identities, this is a sum to product identity.
So it would be 2 the A, right?
So it'd be 2 cosine and then the x plus y over 2. Do you see that?
Uh-huh.
Yeah, so x and y are 6 and 4. So when you add them together, you get 10 divided by 2. So then you get 2 cosine of 5. And then you get sine of 6 minus 4 over 2.
X minus y, so 6 minus 4 so 1. So correct. It's A, right?
Yes.
Yeah.
And then the next one, so you get cosine squared 6 minus sine squared 6. And this one was, where did I see it?
Double angle identity?
Yes. So it'd be the x's, which are the same, times 2. So it'd be B. So cosine of 12.
Yep.
And then the next one, so cosine 6 minus cosine 4. So this is another sum to product identities. So if you look at the bottom one, cosine x minus cosine y, so it's -2 sine of x plus y over 2. So it's 6 plus 4 over 2, which is 5, or 10 over 2, 5. We get sine 5, and then sine of x minus y over 2, which is 6 minus 4, which is 2 over 2, which is 1. So it'd be d.
Okay.
And then by process of elimination, you get e as the last one. And then just to explain that one, what you would use the power reducing identities, which they say are not in the textbook.
Oh.
Yeah, but on the paper that they give us.
Yeah, just on that paper.
So it would be the cos. Yeah, so e. That makes sense because it's cosine squared x. How do you say it? I don't ever remember how to say things.
I just say it like that. I say cosine squared x.
Okay. But even if it wasn't by elimination, we would know that because that's what the power reducing identity says.
Yeah.
All right.
Everybody good on that?
Yeah.
Okay.
I am.
So next, so it says the proof of the first product to sum identities is given to you in the text, or given to you in the e-text. The proofs for the other 3 identities can be found using similar techniques. Show the proof for one of the other 3 identities in the space below. So it says a proof of the first product to sum identity. So where is that in the textbook?
Say
It's on the, yeah, it's on that worksheet we downloaded, I thought.
Oh, is it on that one? Well, so it says it gives you the first one. Or
the first one's on the textbook.
Yeah, and then it says that for the other 3, you can be found using similar techniques. Show proof for one of the other 3 in the space below. So I'm trying to see how they prove it in the textbook, and then we would just do the same for the other ones.
Yeah.
So what was it again? Product to sum.
Product to sum. Yep.
Alrighty, what page is that on? Okay, so it's on page. What page is that? 459.
$4.59.
Yes.
My e-text is trying to pull up. Sure, guys, is the internet slower? I guess it wouldn't matter because we're not having on the same internet. Never mind. Are your guys' other teachers, are they like a little bit lighter this week? Or about the same?
No.
For my online classes, not really.
Yeah, that's
Every
I
teacher.
have one class that was like, instead of Friday, it will be, or Saturday, it will do Monday. Everybody else is light and I'll get it done. I'm like, okay.
Yeah.
Did you guys get that page up?
Mine's still
I
loading.
just
So
did.
No worries.
almost there.
So they do. So they give the one that is on that worksheet we downloaded.
Yeah, so they did the sine a plus b equals da 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 da, and then they solved for that one.
Yeah.
So what we have to do is we have to solve for the other one, like whichever other one we want to choose.
Well, since they did those, could we do the cosine a plus b and a minus b?
Is that like similar? Or
Yeah, because well, it says product to sum. It said they added the sine a plus b and then sine a minus b all together, and then divided each side by 2 to get the identity of sine a cosine b. So I think if we did that with the cosine a plus b and then cosine a minus b and did the same thing, it would be similar, right?
oh, I see what they did. So what they're saying is so the product of some identities they say they added the first 2 identities together.
Yeah, and then divided by each side by 2.
Yeah. So I guess we would do that for the cosine part. So with cosine A plus B equals cosine A cosine B minus sine A sine B, and then we're going to add that with cosine of A minus B. And then that equals cosine A cosine B plus sine A and sine B. So if we add those together, what we get is cosine A plus B plus cosine of A minus B equals
Wouldn't it just be 2 cosine A and then cosine B?
you said cosine A cosine B.
No, that won't work. Just kidding. It would be, wouldn't it? I think it would just be, let me think. I think the signs go away because there's a plus and a minus, so those go away. So then we would have 2 cosine A cosine B.
Yeah.
Is that what you said? Sorry.
No, I was agreeing with what you were saying. So 2 cosine A, 2 cosine B, right? Because the signs cancel out.
Yeah. But
Yeah.
I think it's just 2 in the front because I think that whole thing is 1.
Yeah, so everything will be in terms of cosine, because that's what identity is.
So the sign goes away, the sign that side, and then it's just 2 cosine A cosine B.
Yes. And then
That's what I got because the same things.
And then you divide
And
2.
so not 2 cosine A.
Yeah, so what you get is cosine A cosine B equals 1/2 times parentheses cosine A plus B plus cosine of A minus B, all in parentheses.
Yeah.
Oh, well, I guess they have the A minus.
Which is that one of them that works. Yeah.
Okay. Okay, so we got that one.
Okay. Go back.
So number 3 says find all the angles in A in 0 to 2 that satisfy the equation sine 2A equals 10. Okay.
That's kind of like what we just did.
I believe so.
Yeah.
So we need to get everything set to 0, right?
Yeah.
So
And we need to probably change the tangent into cosine and sine, right?
yes. So what we would do, I think, can we pull that 2 out of the A out of the?
Yeah. I think we can. And have 2 sine A.
Yeah, does that make sense? Will that work?
Yeah.
Yeah,
Okay.
because if you put it back in, it would do.
Yeah, that's how you take it out of there. Is the 2 times sine, wouldn't it?
Yeah.
I think it makes sense.
I can't remember.
So what we get is 2 sine A equals tan A.
Okay.
And then we
We
would
want to move the tan over and then put it into cosine and sine.
yeah. So what we'd do is we'd have 2 sine A minus tan A equals 0, and then change that to 2 sine A minus, and then in parentheses, sine of A over cosine of A equals 0. And then from there, we could pull out a sine, right? Pull that out of the whole thing.
No, because they're minus, so we have to actually add find a common denominator. So we'd have to times the 2 sine by cosine A, right? To get to have those cancel out?
Well, I was saying if you factor out a sign, you'd have sine parentheses 2 minus 1 over cosine A equals 0. Does that make sense?
Yeah, but can you do that when it's not combined yet? I guess you can. Never mind.
But if you're just factoring, right?
Yeah. So you're saying take a sign out, so then you have 2A minus A over cosine.
Well, so the A's would have to stay with each other.
Oh, yeah, that's right.
So what I was saying is you get sine of A, and then parentheses 2 minus 1 over cosine of A equals 0. And then you would just solve for each of those, right? So you get one A, or the first A for sine of A. So if you set sine of A to 0, what angles does that give you?
If sine is 0, that would make that would be angles.
0 and 180, right?
Uh-huh. 0, 180.
A 0, 180. And then for the other one, if you set 2 minus 1 over cosine of A to 0, which just simplifies to 1 minus, or 2 minus the secant of A equals 0. And if you add the secant to the other side, so 2 equals the secant of A. And then, or maybe I just made that too complicated. Because now we have to find what angle is the secant of, or shoot.
I'm lost, sorry.
No, I think I messed this up. Are you seeing anything, Antonio? Did I take an extra?
I got a little lost. I'm just trying to figure out. I'm still not very good with the identity stuff. So I don't know which one's used when you change the tangent to the sine minus cosine. That just means the sine over the cosine, right? No.
Yeah, that's what we did. We changed it over to sine over cosine.
Okay. Sorry.
No worries.
So then wouldn't you take out because that, never mind. I don't know where I'm going with this.
Maybe I
Let me write it out.
Supposed to, because you know how we found the sine, right, of A?
Yeah.
Set that to 0. Now it's just a little harder when we set
it to the one or the secant or
Yeah.
1.
And maybe that's where maybe I just did that when I wasn't supposed to. Maybe I just made it a little more complicated.
Yeah.
I'm trying to see if there's any identities that we could have used.
Yeah, I'm looking through my okay.
Well, I guess what you could also have done instead of what we did is just set each side to 0.
Oh, that's true.
Sine 2a equals 0. You just divide by 2, which would still be 0, and then be sine a equals 0. And then we'd set tangent of a to 0, which would have to mean every sine over cosine would have to equal 0, and we could figure that out.
And so then the angle would be 0, 90, 180, 270.
That would make sense, though, right?
Because that would be cosine, though. If the cosine was 0, then it would just actually be 90 and 270.
Yeah, but since it's tangent, it would have to be every angle, so every sine would have to be 0.
So the only one with sine would be 0 and 180.
So it'd be 0 and 180 would be the angles, right?
Mm-hmm. For sine of 0, those are the only ones.
Let me see here. But so can we actually do that if we set each side to 0 though? Because it's pretty much just solving the same way, right?
So what about the reciprocal identities? Like, okay, so if we did cotangent A equals 1 over tan, and that's just cosine over sine, could we rearrange it somehow that way? Hold on. Let me try something. So what if we did at the very beginning, change it to all sines and cosines, and then we could times cosine A over to the other side. It would be cosine A times sine 2A equals sine A. And then I think there's an identity for something out of that. Or is it other?
Wait, say that one more time.
Oh, I like at the beginning I put tangent everything in terms of sine and cosine. So then you have sine 2A equals sine A over cosine A, and then I times cosine A by each side to get it all into like a one formula instead of dealing with fractions. So then it would be cosine A sine 2A equals sine A. And then I'm trying to see if there's an identity that is solve from there.
Do you have that written down? I don't know why I can't like see it.
Sorry, it's just on scrap paper, so I don't know.
No, it's okay.
I'm just trying to see.
Oh, cosine A times sine 2A equals sine A. Okay, I see what you're doing.
I just got rid of the fraction.
Yeah, that's multiplied, right? Cosine A times.
Yeah, sorry, multiplied.
No, no worries. Yeah, I see that. You're looking at the identities.
No, I'm trying to find an identity that. I mean, let's have to do something with that 2A, but.
Well, oh shoot, no, you can't do that. I guess I'm looking at the double angles identity. So I guess what my idea would be is like the first extension problem that we did is we get everything in terms of one sine, you know, or like sine or cosine.
Okay.
So I'm trying to see here because there's the double angle identities. There's a sine of 2x
Equals 2 sine x cosine. So that would work if we factored out the 2, all right?
Well, so what it would do is it would change. Yeah, because if we change that to 2 sine cosine x, and then if we multiplied cosine a from the right side onto the other side, it would cancel out the cosine. So you'd be left with 2 sine a equals sine.
Okay.
You see how I got there?
Yeah.
So let me try to write this out again. So we change 2. So we change the sine to a. So we change that to 2 sine of a cosine of a equals sine of a over cosine of a, right? And then if we multiply the cosine of a over the other side, or no. Oh, yeah, no, that wouldn't work. Dang it, I thought I had something.
So sine of a, we could write it as 1 over sine of a.
1 over sine of a?
Yeah, the reciprocal identity. So sine a equals 1 over cosecant a. And then if you look up at the definition, cosecant a is 1 over sine a.
Okay, so which part were you changing that to?
I think on the right-hand side, because then we could sine by a. And then we would get sine squared a, which I think, I don't know. I'm looking at all the identities and trying to make it fit.
Shoot.
I'm gonna look in the book here.
Sine to a. I feel like that has to do with something. I don't know why. I just have this feeling that it's supposed to do something. Yeah, I'm going to find all angles. Okay. That's not it. Which chapter are we on again?
6.
6.
This is really fun. All the examples in the book I'm seeing are all like give you an actual number to work with versus.
Okay, wait. Okay, I see one on here that says, so it says find all solutions in interval 0 to 2 pi of sine 2x equals sine x. This is on page 472.
Okay.
So this one may be very similar.
Oh.
You see that? Maybe that would give us a clue of where to go.
I think we can at least do that one side. So they changed sine 2x, which is like the 2a, so to 2 sine x cosine x equals r tangent a. And then subtract tangent to the other side and factor. And then set each factor equal to 0. And then that will give us our angle. So maybe we should keep it as tangent, or should we change everything to cosine and sine?
Well, so if we
What would be easier to work with?
So this is just like the thing that we were doing earlier. It was just the part of solving the other. So we did sine of A, which we found was 0 and 180 degrees. It was just trying to figure out what the other side equaled, you know?
Yeah.
So do we want?
I'm gonna try seeing what it will do if I'm.
So if I bring it down to 0 like they did here, when you get to the two factors, I get sine of A outside of 2 cosine A minus 1 over cosine A equals 0.
Okay. I guess I'm stuck on I'm confused about how you would be able to find it when you don't have a number. Am I just crazy?
All right. So what we know for sure is we know sine of A when it equals 0 is 0 degrees and 180.
Mm-hmm.
And now we have to set 2 cosine of A minus 1 cosine of A to 0.
Okay. You have to have a common.
Well, so what I would do is, so 2 cosine A minus 1 over cosine A equals 0. So if I add 1 over cosine A to the other side, so then you get 2 cosine A equals 1 over cosine A.
Which is.
Do you see what part I'm at?
Yeah, I see that.
And then if I divide by cosine to the other side again, it's just like multiplying 1 over cosine. So what you get is 1 over cosine squared A, which would equal squared. And secant squared would equal 2.
Okay, so we're looking for cosine.
That's just one way that I'm looking at it as.
Well, if we follow the example, it says cosine is 1/2. You see that?
Yeah, because they added the two. They added the.
So if its cosine is 1/2, then it could be pi or 60 degrees or 120 degrees as well.
Wait, were you seeing that again? I'm sorry.
Oh, I'm just saying if cosine is 1/2 on the unit circle, that's if it's positive, it's 60 degrees, and if it's negative, it's 120 degrees.
Yeah.
So that make our angles 0, 180, 120, and 60.
Wait, how did? Oh my goodness, I'm so lost.
Sorry, I'm just looking at the.
Oh, you're just looking at the example.
Yeah.
Oh, okay. I thought you were looking at our problem. I was like, where are you getting 1/2 from?
No. But I'm thinking if we can make that work, I think the tangent. I mean, that's what's throwing me off is the tangent.
Yeah, the tangent part's not helping. I think we're on the right track. It's just we're solving for that other 0, which is hard to do.
Let me look in the book again. I hate how the book is like so simple, like uses simple examples, and then the stupid quizzes are like.
Yeah.
That's crazy.
I'm brought down with this chapter, so.
Yeah.
Honestly.
Did you guys get rid of the fractions? I can't remember if you said you did or not.
I think we've tried it a couple ways. I feel like it's easier to do it that way because but then I get stuck on how to do it after I get cosine x times sine 2x equals sine x.
So, when I was asking, the reason I was confused before, when you guys just put the sine minus cosine x in the parentheses, is because I was doing it where if you move the tangent over, and so you would have the sine 2x minus the sine over, or actually I wrote it the other way. Wow. I wrote it negative sine theta over cosine theta plus sine 2 theta or 2a or whatever. And then I just kind of got rid of that by making it all into fractions. So I just put a 1 underneath the sine 2a. So I just kind of got the least common denominator. So you would just multiply the sine 2x a and the 1 by cosine A. So you would have negative sine A plus cosine A times sine 2A over cosine A. And so that would just kind of get rid of the cosine A. So you would just be left with the negative sine A plus cosine A times sine 2A equals 0. And then after that, that's where I get stuck. I don't know where to go from there. I don't know if you, to get that 2, I don't know if you have to get rid of that 2 out of that A. I don't know if you can just put it in front of that sign or if it has to go in front of everything there.
So what's the last part of that equation that you were saying? You said negative sine A?
Yeah, negative sine A plus cosine A times sine 2A equals 0.
Hmm.
Oh, this drives me nuts.
Yeah. I don't see any identity that would. Oh gosh. I hate how long these things take too. Okay. Okay, so sine 2x is the same as 2 sine x cosine x, right? I'm going to try writing it that way. And then we're going to do, I'm saying x instead of a, just because that's easier for me to write down, just so you know. Okay. And I'm going to times the cosine a over to the other side. And that gives us 2 cosine squared x sine x equals sine x. And then I'll cross multiply. Okay. I think I might have a possible. So I'm going to do 2 sine x cosine x equals sine x over cosine x times the cosine to both sides. 2 cosine squared x sine x equals sine x. And then if we like cross multiply, that makes it sine x and then parentheses 2 cosine squared x minus 1 equals 0. And then I think we take those two equations and solve for that. So then we have sine So sine x equals 0, and then 2 cosine squared x minus 1 equals 0. Then cosine squared x, and then add it to the other side equals 1/2. So sine of x, we already know that one, so I'm not worried about that one. And then we have to do plus or minus. So plus or minus square root of 1/2 for cosine.
Square root of 1/2, the cosine.
I think so.
The cosine x equals plus or minus the square root of 1/2 is what you're saying.
Yeah, so I don't know if that is making sense. But down this one.
No, I see you on that.
So then cosine of 1/2 would be 3 pi. Where am I? 3 pi over 4, which is 135 degrees. Oh, just kidding. Please hold.
I think you're getting close on that.
Oh, it was,
I think you were right on 3 pi over 4. I'm just trying to see how.
oh, because it's negative. Okay, negative 1 over square root 2, but if we rationalize it, it becomes square root 2 over 2. So then 3 pi over 4 cosine is negative square root 2 over 2.
Yes. Yes.
And then,
Yes.
so then 5 pi over 4 would be the same thing.
Okay.
But,
Do you mind holding that up, how you factor that all out?
yeah, let me write it out nicer. So if you times 1 square root 2 by square root of 2. Oh, sorry, I didn't do the. So this becomes.
Yeah. Okay. Let me just see this real quick. So, okay, so you did that. So you did cosine of A. Boom, boom. Cosine of A. Okay. Do you mind moving it to the left just a little bit?
This way, or?
Yeah. And then you change that. So you got 2 cosine squared A plus sine A equals sine A. And then you subtracted the sine over. So you get 2 cosine A sine A minus sine of A. And you factor that sine out, so you get sine of A sine of A minus 2 cosine squared A minus 1 equals 0, and then you just set 2 cosine A minus 1 equals 0. 2 cosine A equals 1. Cosine squared A equals 1/2. Square root, so cosine of A equals plus or minus square root of 1/2. And then you have to rationalize it, so you get why was it negative again? Negative 1 over square root of 2.
Oh, I think it's plus or minus.
Oh,
I just did that part because you're taking the square root of it.
Oh, okay.
So then, because then I think then.
The cosine of A equals plus or minus square root of 2 over 2, right?
Square root of 2 over 2, yeah.
And those give us those angles.
And then, so then we also have to do the positive side. So then our other angles are pi over 4 and 7 pi over 4. So our angles altogether are going to be, oh, when you're ready, I'll tell you.
It's going to be 45 degrees.
Yeah, so 0, 45, 135, 80, sorry, 180, 225, and 315.
About 6. Right? Yes.
Does that make sense to everyone?
Yes. As long as that makes complete sense. Goodness gracious.
And I'm sorry if it's wrong, but it
No.
makes sense to me.
Yeah.
I think it's just that part where you said you rationalized it. That's the part that made sense, or I couldn't understand until you said that.
Oh, yeah. Okay.
So,
Okay, last one. Find an appropriate identity to find the exact value of the expression sine of 285 degrees minus sine of 15 degrees. These on the homework.
I think I remember seeing this in the book as well. Is they use the, where is it? The
Sum to product identity?
Yeah. But they didn't actually they didn't actually find the exact answers. They left it in terms of the degrees. That's what I saw in the book. But, because where was it? Where did I see that?
If you go to page 461, it'll start to tell you about it.
461?
Yeah.
So the homework only had a product to sum.
They actually give you
I think
some.
Oh, sorry. Go ahead.
No, you go ahead.
No, I think we could use, so A would be 285 and B would be 15. So I think that, why don't you do the 1/2 sine of A plus B plus sine of A minus B?
Yeah, so we can input everything. I'm just saying when it says find, I don't know if they actually used a calculator or not to find the exact numbers. That's what I was saying.
Yeah, I think you do keep it in the degrees. Like, this is from the homework. I don't know if you can see it on.
Yeah.
And you didn't really solve it. You just put it as, so it would be, I think the equation would be sine. Oh, this is sine and cosine. Dang it.
Would be.
So we have sine and sine, and it's a negative. So then it would be cosine A sine B equals 1/2 sine A plus B minus sine A minus B. So I think we use the product to sum. Or I guess.
Would it be the product to sum,
Oh,
or would it be the product?
Sum to product. So we have a sine minus sine. So the identity says sine x minus sine y equals 2 cosine, in parentheses, x plus y over 2, sine of x minus y over 2. So I think we could just do, so 2 cosine, and then it would be 285 plus 15 divided by 2 times sine 285 minus 15 over 2. And then we could simplify it out down.
That's y over 2. sine of x minus y over 2. So we get 2 cosine of 285 plus 15 over 2. And then sine of 285 minus 15 over 2. So we get 2 cosine of, what does that reduce down to? 285 plus 15. That's 150.
Yeah.
And then, so 285 minus 15 divided by 2 is 135. So I get 2 cosine of 150 sine of 135 as the answer, right? And that's what we leave it in?
Yeah, I think that's what we leave it in. So 2 cosine 150 times sine 135. I think that's what it would be because that's the identity that we used. And you can't really, well, I guess you could figure it out. But in the homework, you didn't have to, like.
We could just check it and make sure, but I'm pretty sure it'll come up to be what the top one was.
That's what
What the original was. Sorry. I checked it. I
equal to each side, so that is the exact, because you can't. It's equal to what they gave us, so that's as far as you can go, right?
Yeah, because we put it into the identity and then just simplified it.
Yeah, I think that would be the answer then, just the 2 cosine 150 sine 135.
Okay.
What do you guys think? Do you think that's kosher?
Yeah, I would stick with that.
Yeah.
Because all the homework, that's as far as it went in the homework, so I don't think.
Yeah.
At least the first part.
Okay.
Okay, I think we're good then.
Yeah, I got all that.
And then we're going to meet Saturday at 10 to go over the extension problems before we take our tests.
Yes.
Yeah.
Okay. All right, I'm going to stop this then, and I'll put the link in the Google Hangout, so when you submit it in.
Oh, with the quiz?
Or I guess I'll submit the
link
in, and then if you'll just do the quiz, does that sound good?
Yeah, that'll work.
Okay.
And then I just have to put participations on the group quiz as well, right?
I think I do it with the link to the video.
Oh, okay. So I just have to submit the quiz.
Yeah, I mean you can put it on there. You could just write it on there before you scan it if you wanted.
Okay. Yeah, I'll do that just in case.
Yeah. Okay. Cool. Thanks, guys.
Yep. Thank you so much, guys. Good stuff.
Yeah.
Right. See you.
Happy Thanksgiving.
Yep. You too.
Yes, too. Bye.